So welcome, everybody. I'm John Dodge.
This is Levin Chang.
And this is Demystifying Large-Scale Enterprise View Architecture with Tales from the Lighthouse. Our Lighthouse program is our enterprise marquee accounts, and we work with these customers to make them successful, and then we turn around and we use them for references. And so we've learned quite a lot over the years by engaging with these customers. And so I'm going to share some of those stories. But I think when we talk about large scale, what do we really care about? How many desktops can we get in view? Is that something interesting that you guys want to talk about? So, Levin, what's the largest number of users that we can run on View?
A lot.
Well, is there a number?
Throw me a number. I can do any number.
You could do any number?
Yes, it's easy.
It's easy. I could do any number. Do you guys do you believe him? I'm not sure I believe you. I think we should have a little wager.
Throw me a number.
I think we should bet on it.
Okay, sure. Show me the money. Let's bet on it.
All right. I will bet you $20.
Okay, you in front of so many people, so you count.
$20. All right. Help me find the number. What number do you think will stump him? Let's try to stump him. What's the number? 50,000. Can we do 50,000? Do I hear 100,000? 240,000. Do I hear 241?
This is not an auction, but let's go with 240.
All right. 200,000 users. You're saying that we could run 200,000 users in View.
Yeah, and I can walk you through how to do it in 5 minutes. Actually,
all right, so now we have a bet going. I got a little wager going here with Levin. I want you guys to be the judge on this, okay? Can you help me with that? You're going to judge whether or not we win this argument, because I don't think that's true. I think you're exaggerating. 200,000 users in View, don't believe it, not for a second.
Okay.
All right, how do you do 200,000 users in View?
All right, so let me ask a question back.
All right.
So you do so many installation, you're the expert in implementation, so let's say 200. Can you do 200 user?
Anybody here running 200 users in View today? Obviously. Oh, a few of them. So we already have people doing 200. So
you're in the wrong session, man. This is an advanced session. If you cannot do 200 easily, you should go to how do I do VDI 101. Sorry, don't mean that.
So 200 users.
That's easy.
Okay,
right?
I don't
Everybody
understand.
agree?
200 users is very easy, but how does that get me to 200,000?
What is 200,000 compared to 200? You do it 1,000 times.
I don't know. That sounds bogus. What do you guys think? So we're just going to do.
You can do easily 200 and then do it 1,000 times. You'll get to 200,000.
That's true. I mean, he's technically right. What do you guys think? What's the problem with that approach? Not yet, but we're going to talk about that.
Right, but the question was, 200,000.
What's the number?
What's the number? And actually, in some comparison, in some articles, people just talk about what's the biggest. What's the number? Well, pick any number. If you have a big enough team, you have big enough time.
You have time, you can
iterate. Do 200,000 very easily. Just repeat 200 1,000 times. You never tell me you have to manage it. You never tell me you have to change the image of it. You just say, what's the biggest number? Don't be fooled by the number. That's right.
And I think sometimes people kind of put us in that box and say, well, when I talk to customers, they want to know what's the largest deployment. It really isn't about the largest deployment number, is it? It really is, can I get to that very large number and manage them? Is it a single pane of glass, or is it a finite set of well-controlled processes? And that makes a lot of sense. So who do you think won this bet? Did I win or did Levin win?
Show of hands if John win.
Show of hands. Who thinks I won? I don't know. Levin?
Oh, wow.
Oh, you won. He won this time. All right, there you go.
All right, thank you.
See, I won last time, so. All right, very good. Well, why don't we tell him what we're going to tell him?
Exactly. So what we are going to tell you is not about what is the largest scale, what are the number. We are going to tell you what is behind those numbers. How do you manage when the scale? Not just win a $20 bet, but really get into the detail as to if you have such a large scale, how do you go about managing it? And what we are doing, since I'm a product manager, what we are doing, hearing from customer, what are the features, what are major architectural design we have in the future to make it easier, to make it sometimes possible to manage, say, a scale of 200,000. Okay?
And by the way, I'm in our technical marketing team, and I focus on end user technical enablement. So I get to work with customers and partners, helping them cope with these scalability issues. I get them to figure out their processes, and I help them adopt the product. So let's get started, shall we?
Yep.
So in this session today, we do have some discussion about what's coming. And so that does make this a NDA presentation. So this disclaimer slide doesn't apply to all the sessions at VMworld, and the legal team makes us put it in every single deck. But in this particular case, we are talking about things that are coming. And so please tweet responsibly and do not share any of the information about our forward-looking products. Fair enough? Everyone agree? Don't make me come around with a waiver, because I will. I will do it. So here's our agenda here. So we're going to talk about how we get to scale. There's a how question. It's not a deep dive. Usually I spend an hour or two working with folks and drilling into that. But we're going to talk about what makes a large-scale view design elegant and effective. We're going to talk about some of the things that sort of keep these large-scale deployments down, the downward pressure on these large-scale deployments. So you could understand what's going on under the hood of View, and you understand how to scale properly. Because there have been some customers who have tried to scale irresponsibly, I'll say, and so they didn't understand enough about how the product worked, and they did some things that hurt them. And so we'll talk about some of the issues relating to large-scale View, and then Leben is going to give you the outlook, what's coming in the product over the next couple of years. And there's some really great features, and there's some real excitement there. Sound like a good agenda, Leben?
Yeah. Oh, we can change it right here in front of you.
I can. I've been known to do that too. So what I wanted to start with is just a very quick introduction to what we call the View pod and block architecture. So the question is sometimes, what is the largest number of users in a single pane of glass? And I've already had somebody who asked me that question. So our supported number right now is 10,000 users to a View pod, and we're going to tell you how to scale even beyond that. But how do we get to 10,000? So we have this logical architecture approach where we have a management block and desktop blocks. Now, what are these blocks? I'm going to explore them. But first of all, I want you to think in terms of this little thin green line here is basically extending virtual machines that are in this management block, which aligns to a vSphere cluster. So I put my management VMs inside the management block, and they therefore manage virtual machines in other desktop blocks. And I believe this is going to make a lot more sense in a minute. And so this is a logical architecture, and it rests on top of the vSphere layer. And of course, we haven't yet been able to totally virtualize hardware and make hardware irrelevant to this. We're working on that. I think that's going to be a really hard challenge. So ultimately, we have to run on hardware somewhere. And so vSphere is installed on the hardware, and so that is the overarching logical structure here. The way we get to 10,000 is through disciplined execution. Now, that might sound like a mouthful. But if you think about it, if you look at the speed rating on the tires of your car, you might find that the tires are speed rated for about, what would you say, how many miles per hour? 100, 130, 140 miles an hour. Do you think it's a good idea to drive everywhere at 140 miles an hour? You know, I'm going to head down to Starbucks for a cup of coffee. I'm going to drive 140 miles an hour past the school. Doesn't make a lot of sense. So what happens when we drive at 140 miles an hour? We're at the breaking point. We are literally stretching the limits of the vehicle and the tires and whatnot. And what happens if that tire isn't quite up to spec? We have a blowout, we have a terrible wreck. So to get to 10,000 desktops in a single view pod, a single pane of glass, means that you need disciplined execution. You have to be a good driver to drive to Starbucks at 140 miles an hour and not hurt somebody. And so to get to 10,000 desktops, you need solid processes. You need well-educated people. You need good networking, good storage, good ESX design, et cetera, et cetera. Does that make sense? All right. So what do we do? How do we get to these very large numbers? And I'm going to step you through the major steps. First of all, we're going to segment our users into groups. We're going to segment those users by use case is what we're saying. And so we can group use case by their operating system needs, because of their application needs, because of their mobility factors. Do I go offline sometimes? Am I online sometimes? Am I always online? And then their collaboration needs. Who are they talking to? When do they need to collaborate? How do they collaborate? Once we have that established, then we're going to segment them. So, we might have the IT group. We've got our telecommuters spread out all over the place. We've got our offshore developers that maybe are sitting in one location that's separated from headquarters by a long distance WAN link. Then we have the call center, very densely packed. We're dialing for dollars in the call center, so it's really important that I get density and really good performance. So once I have those users segmented, now you can kind of think about how do I align them to VMware View. And so we make the leap from use case to desktop pools. And in some cases, our desktop pool is large enough to hold the number of users. So what's the recommended maximum for the number of users in a desktop pool, Levin?
It's not really just the number of users, but actually how big you can make the pool. Because currently the pool concept is around some physical properties, such as the clusters, and you're limited by the cluster size. But also, not to give up too much in the later slides, also by the throughput at which you can operate.
That's right.
Against
so
this number.
There's a lot of factors.
Right. So normally what we see, in the customer side is around 500 is starting to tapering off. When it gets to 1,000, also, a certain operation you really need to optimize for it to. Somebody looking for you?
Yeah, I got a text message. Sorry, be right with you guys. Just kidding.
So be some of the large scale customers.
It's a large scale question. Somebody was just asking me, is there a number of users to the pool? So that is annoying. I'm so sorry. So again, the speed rating on the side of the tire, 140 miles an hour. In this case, the speed rating for the size of pools is about 1,000. We test up to 1,000. We don't recommend you go beyond 1,000, but really your mileage may vary, and so we really suggest that you probably stay below that. But in the last slide, I've showed you that I've segmented my users into very large groups. So what do I do when I have more than 500 users in a use case? In that case, we're starting to think about this concept that I like to call the meta pool. It's a very large pool. It's a pool of pools, and that's what we sort of end up with here. So, maybe IT fits into one desktop pool, offshore developers, but then I start to get to these extremely large use cases, and that's my telecommuters. So now I've got 2 desktop pools. Maybe my call center's a lot of users in there. It's very densely packed. So now I've got 6 desktop pools, and I want you to keep this meta pool concept in the back of your head, because we're going to be talking about it in a minute. So designing for View, after I've got my users segmented and I figured out how many pools I need, now I need to place those pools into this pod and block architecture that I showed you. So you can see this green layer doesn't have any desktop pools in it, because that's where I put the server VMs behind my View infrastructure. So things like connection servers, security servers, vCenter servers, View Composer servers, et cetera, et cetera. These are server workloads. And what do we know about the workload characteristics of servers and desktops? Desktops are extremely volatile. Servers are not. By volatile, I mean sometimes the desktops are nearly idle, and sometimes they're bursting incredibly. So we have a lot of this volatility up and down. Server workloads tend to be much more steady state. And so the idea is that as I place my virtual machines, I want to make sure that I'm not putting conflicting workload characteristics together. I don't want my desktop volatility to interfere with my brokering function, for example, because then that likewise has a reverberation on the desktop workloads. And now I've got users who are not delighted. I have users who are annoyed. So what we advise is that you put the server infrastructure virtual machines in a dedicated vSphere cluster separate from the desktop pools. And so now we step through our design and architecture. So we start to divide up our vSphere layer into clusters. And one thing to know about our product today is that desktop pools are constrained in a vSphere cluster. And so you could see that I've got the pools resting on top of a block. I've got the block resting on top of a vSphere cluster. And eventually I come all the way down to the hardware layer. And I have to finally figure out how am I going to serve up the compute needs and storage needs of all these users. And so that's the correct approach to scaling Vue. We have to take a very logical, orderly approach and use disciplined execution to get there. So what are the important things you need to know about Vue that relate to scale? There's a few things that I'm going to talk about next. First of all, it's the Vue agent to cluster communication actually has a very important role and is a constraining factor in some cases to our large-scale architecture. We used to poll the agents twice a minute to find out what they were doing. It was a little annoying. It was kind of like, hey, Levin, what are you doing now? What are you doing now? What are you doing now? Twice a minute, we used to ask the agents. And every connection broker would do that. So it's like, hey, what are you doing now? 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 So it was very chatty. So we switched to an asynchronous update. So now the connection broker sort of has this approach of, are you good? When something changes, tell me. And so we now have an asynchronous update process. So when something happens at the virtual machine, a user logs on, a user disconnects, a user reconnects, user locks off, we finish provisioning, there's been some problem in the virtual machine. I'm going to send a update to the broker. Something else to know is that when the virtual machine comes online, it randomly picks a connection server in the cluster, and they become joined at the head. Meaning that if you were to go to a connection server console and do a netstat, you're going to see TCP connections on port 4001 to all these Vue agents. So when the agent comes online, it picks a broker to communicate with, and that's where the messages go. So how does the rest of the cluster find out about it? The connection broker, having received the asynchronous update from the agent, then notifies its peer in the cluster. So here comes a message from the agent. I'm going to broadcast it inside the cluster. And really what it means is I've got two messages going among my peers in the cluster. So now the fact is that an agent has something to say, and now the connection broker has to tell everybody. So we got away from the, what are you doing now? What are you doing now? What are you doing now? To connection brokers that are much more chatty in later versions of Vue because they're telling each other what's going on. So you can imagine that this has an effect at scale because now we've got agents giving us asynchronous updates. We've got connection servers that are trying to tell each other what's going on, and then I've got lots of desktops that are coming in here. So this has some very serious implications on the connectivity between connection servers. It's very, very important to have a well-connected, low-latency LAN between connection servers, and let's look at exactly why that is. So there's really two kinds of data that connection brokers need to exchange with one another. The first is the configuration and entitlement data, and we use Atom for that. And as you know, Atom is basically using the same replication as Active Directory. So is there any problems with large-scale Active Directory environments? Do you think they handle latency pretty well? Anybody know of any Active Directories over 1,000 and separated by WAN link? Yeah, of course. Microsoft figured this out long ago. So Atom can handle latency, no problem. But the other data that we have in our Vue cluster is what we call session state data. We basically create a session state map. This is what desktops are available and what state are they in. And we put it in memory for a really good reason. If we're going to pull it out of a database, that's a very expensive, slow-moving transaction. So instead, we keep all of this session state data in memory so that we could broker very quickly. And to do that quickly and to keep it in memory, I have to send updates very quickly among my peers in the cluster. And we use JMS to replicate this data. And the implication in large scale is that if there's any latency, it could potentially mean that a user coming in to be brokered to a desktop receives stale information. So I didn't know that broker A has already assigned desktop number 1. I'm broker B, and I'm also trying to broker to desktop number 1. And so that's a bad thing for us. So we need to make sure that there's no latency in the network connection in the cluster. Now, does that mean that nobody has been able to survive in high latency cluster scenarios? No, there are some guidelines. First of all, we don't support stretching view connection brokers across WAN links for this latency reason. But we do know that you can get to about 4 milliseconds one-way latency in a cluster successfully. But if it's over 4 milliseconds, this could be fatal to the entire cluster. The reason is that we've got these messages that have to get delivered very, very quickly. If they're not delivered quickly, they have to be queued because they're very important messages. And if the queue gets too large, we get a buffer overflow condition. The connection server can crash with an out-of-memory condition. So we don't support stretching view connection servers across WAN links for this reason, because it's not just, it's not just slightly bad. It's quite epically bad. It could be fatal to the cluster. So maybe over the years you've heard us talk about cluster design in a 5+2 model. And there's a little bit of confusion about what 5+2 means. So getting to scale means that we have to understand how the components scale. So first of all, consider that the largest single pane of glass supported by VMware is 10,000 seats. So let's get to 10,000 seats. So we need about 2,000, we can broker about 2,000 concurrent connections per connection server. We can also broker about 2,000 connections per security server. But you might be looking at the math and thinking, wait a minute, that's, when I last checked, 2 times 7,000 is 14,000. The thing to know about the relationship between a security server and a connection server is that the security server gets all of its configuration info, all of its intelligence from the connection server. So as a result, this is a stovepipe, meaning that a security server is only ever associated with one connection server. If something gets in between that relationship, then the security server goes down because it doesn't know what to do. And if I were to try to connect to this connection server, bypassing the security server, let's say I'm inside the LAN and I could still access that connection server, I still end up with a tunneled connection. Whereas with these connection servers, I could either tunnel or go directly to the desktop based on pool configuration. So that's something very important to know about configuration. Anything to add to that, Levin?
No, you covered it all right.
I'm not going to bet you again. I lost the last bet.
How many $20 bill you have?
So how do we use this information to scale very large? I told you, don't split connection servers across WAN links, for example. Watch out for latency, et cetera, et cetera. So let's talk about this scenario where I've got 20,000 view users in a building. And I told you that 10,000 is the maximum support, and I want you to be a little bit below that. So one of the ways we could do it is to increase view pods for concurrency. So let's say we've got 3 pods for 20,000 users. That's roughly 7,000. I'm no math major. But that's roughly 7,000 users per pod, and we want to just add multiple pods. The other way to do it is I might split for network latency. So let's say I've got 2 buildings separated by a WAN link. The right thing to do is to create a new pod at the other location. So now I've got a total of 4 pods for about 23,000 users. So that's the responsible way to scale. But we have some good news coming that Levin's going to share with you.
All right. So before that, I would like to tell you an interesting story 2 days ago. The same sessions we have, this is a repeat of the other session. But in that case, I think we have a double book situation. So John and I was in a different room. Both the sign says demystifying large-scale customer.
That's right. So this session was basically appearing in 2 rooms at the same time, and we're co-presenters. It wasn't by design. It was just a problem with the signage.
And I called up John and say, hey, where are you?
And I said, hey, where are you?
Exactly. And we do a quick comparison, and we found out that actually John was actually in this room, Moscone West.
Yes.
And the other location is Moscone South, somewhere in room 305. So we do a quick comparison and say, John, you have a small number of audience.
There's a small contingent over here, a large contingent over there.
Say,
So what do you think I did?
And I do a quick search on the bad jokes, I can tell in 5 minutes. And John leading a group of attendees running over here.
In a wind sprint.
And weaving through traffic. And that actually is an illustration of how the two parts, multi-data center failover looks like.
I don't recommend it because I can't wind sprint that many times.
Yeah. And even that, going from west to south take about 5 minutes.
It did.
Yeah, it's agonizing 5 minutes. So that actually underlying some of the assumptions is that, if you set up two pods, in a geographically distributed, this is a map, in Europe, a user cannot travel that fast physically. We still, with the advance of technology, we still cannot travel at light speed or faster than light speed, which is probably impossible. And so the assumption we make here when we are designing a multi-data center situation for view deployment was that we only need to replicate mostly the configuration and the entitlement, while the session information can be delayed a little bit, because just that you would not be able to establish a new session in a totally different geographical location. The use case may not be calling for it. That's why we think we can do away with the requirement with low latency between the two links by doing away with the requirements. So the two parts has to share the session information. They may have to exchange information as to which user has an existing session in your local part or the other local part. And the only time when you need to transfer those sessions over would be either in a disaster recovery situation where one of the parts becomes unavailable, or you really just roam, you travel. And I think we just demonstrated physically, you take about 5 minutes between Moscone West and Moscone South, factoring the traffic and factoring how fast John can run.
Round trip was probably even higher than that.
Exactly. But on top of that, I think the interesting property that we would want to design for a multi-data center view situation was also the meta pool concept that John just illustrated, because very often you have a global population of users that they located geographically in a distributed manner. As well, also they have the number is much more numerous than one physical pool you can support, even if you're expanding, say, a pod from 8 hosts to 32 hosts or whatever. There's a physical limit to that. That's why this also supports the entitlement, a global entitlement, which combined with the single URL, we are not trying to do a F5 or a global load balancer. We are assuming you have one if you need one already. And that global load balancer will take the single URI and to redirect the user to whatever part that's available and that's most suitable given the policy, given the network topology. Then you land it in that part, but you are entitled to a single pool, to a single meta pool. The meta pool has no direct association with the physical pool, the pool that we exist today. The existing pool will be added to the meta pool to support it. So you can imagine a factory concept where you have currently the pool as it is today, and limited to a single part, but then you have a meta pool across that the entitlement to this pool are communicated using a infrequent, latency tolerant, messaging scheme that is a global Atom replication, the same mechanism we use. And we are actively at work to deliver this in the product. It's not available today. We forgot to put the big future stamp on it. But we have a prototype running, and it actually works well. So excellent. Expect this to be in the upcoming releases. We are not allowed to disclose any exact date or but this is something that we are actively working, and I'm very confident that we will deliver this in the future, in the near future. So with that, I want to hand it back to John.
So one of the things I promised you was that I would talk about real-world customer examples of large-scale scenarios, and I'm really happy to do that. So we have an extremely large customer in Tokyo, which is running about 50,000 seats concurrently today. And I learned that they're probably going to order another 50,000 seats. So before long, they're going to be at about 100,000 seats in a single customer. And that's probably one of our largest customers, although we've got a number of accounts that are on that same trajectory. So we know we're going to get there. So a little information about this. This is a public reference architecture that was published. Here are the highlights. The thing to know is that this is on View 4.6 architecture. If you're 50,000 seats, upgrading is something that you don't do, you don't take that effort lightly. So there's a lot of planning and testing involved for them to get to, 5.1. But what they did was they found that although they can get to 10,000 customers and users in a pod, doing so introduced some operational risks. In other words, some of their maintenance windows were running a little long for their comfort. Some of their processes were stretched a little too far. So they found that about 6,000 users per pod was an ideal number for them, even though with something like 100,000 employees in one building, they have multiple data centers. And so really latency wasn't quite the problem that they were having because they were pretty well connected data centers and multiple data centers in one building. And so what they did was went with basically 3 desktop blocks. That's my vCenter server here delineated. And each cluster was about 720 users max. And then they just scaled out linearly to do that. And so brokering at the front was done with behind a F5 load balancer with 4 connection servers in a cluster, in a pod. And I'm going to talk a little bit more about the SQL servers on this upcoming slide. So what they did was they sort of broke out their IT department from their other users. They didn't do that for an architecture reason. They did it for a process reason. So they decided that they would experiment on IT, make sure that the user experience was exactly as intended and important and anticipated. And so then they would roll out the IT architecture to the rest of the business. So one of the things that they were experimenting here was a cluster of, or a group rather, of connection servers for the dedicated pool. And in so doing, they could use a different authentication mechanism from other connection servers in the same cluster. So these are the connection servers for the shared pool. So that's something really interesting to do. If you have a lower security profile, you're a little more relaxed, then you could use maybe single sign-on versus if you think that you have people coming in from less secure endpoints, you could use a 2-factor authentication approach. So behind the scenes, they had a couple of different approaches for the SQL servers that drive our infrastructure. So what they used was a Microsoft failover cluster, and they ran Microsoft SQL Server. They had a dedicated instance for each of the vCenter servers here, so that drove the vCenter server for infrastructure. They broke out, here. I also wanted to point out that they consolidated the database needs on the infrastructure sides for the vCenter database, the Update Manager database, and the Composer database. But they put the event database on a separate SQL cluster. So they considered the value of the data as well as the performance of the database servers behind it. And so what they did was they figured out that the event database is important, but it's also slightly less critical for operations than the vCenter, Composer, and Update Manager database. They're also able to pull out data from the event manager and run custom reports and do some other interesting things. And so they decided, because they had external sources poking into that database, they wanted it separate from the infrastructure databases on the back end. And so next, Leben is going to talk about view operational concurrency. And again, it's all about how it relates to very large scale. So take it away.
Okay. And so in that particular case that John showed, that John mentioned that one of the reasons they limit the pod size to 6,000 was the maintenance windows consideration. they have a maintenance windows for, and also they limit each pool to like 700 desktops. And the reason why for that is mainly driven by the motivation to finish certain operations, such as Recompose, within a maintenance window. In their case, it's about 3 hours. And I want to start out with answering one of the questions that I get asked very often, and I think John get hit by that question. How many of you have a similar questions? Since vSphere 5.0, vCenter claimed that they can support up to 10,000 objects, 10,000 virtual machines, but we recommend around 2,000, and I get a lot of questions about it. How many of you asked that in the past? Or okay, yeah, there's a few hands. So
they're just scared or tired or something. I know. I get this question all the time, and people think it's sort of like they're putting me on the spot. And they say, you tell us that the best practice is to limit number of View virtual machines per vCenter instance to about 2,000 virtual machines. But View supports 10,000. Why? You're just trying to sell me more vCenter licenses, aren't you? I'm like, no, actually, there's a really good reason behind it.
And actually, the View license includes vCenter, so that's not the motivation. And the motivation, this diagram helps illustrate some of the points. So this is one VM going through the Recompose. This is kind of under the cover what happened. And this is actually a simplified diagram. I actually probably skip some of the steps here. And Mark, our brain behind this here, probably can correct me. It's a gross simplification, but still it looks pretty complex, isn't it? And Recompose, meaning you change the image of a pool, and you recompose each VM to the new image. But it's not just one operation. It actually consists of a series of operations. And as you can see, you have to power off the VM first. You have to change the snapshot, reverse the snapshot. And then you have to power on the VM again so that the customization agents can kick in, do some of these things. And then you have to power off and then power back on the VM before it's become ready. And as you can see, some of those lines hitting vCenter and hitting EXX, and some of those operations also need access to the data store. And some of those actually, the time it takes for those operations to complete varies depending on what kind of SAN you're using, what kind of storage technology you're using, how fast your vCenter, how fast your EXX host can finish those operations. So that's why there's a pretty low safe limit. And what happens if you have a high concurrency, you have a lot of operation, because let's imagine you fire up Recompose for hundreds of desktops, then many of this operation will start queuing up simply because we don't have a high enough concurrency limit at those object layer. And today there's only just a queuing mechanism. So from the View perspective or from the View Composer perspective, if I want to say power on this VM, it's a power operation. If I fire that up to the EXX host and the EXX host cannot complete it, or there's a long queue behind, there's a sitting at the queue waiting. So that's why it's a throughput issue, because a lot of, I think over time, you're starting to hear, because the volatile nature of the VDI operations, such as the storage, such as this operation, a lot of this is a throughput issue, not really a capacity issue. vCenter can manage 10,000 objects, 10,000 virtual machines. However, if you want to do certain operations, it's not about a number, as today's PAT illustrated. It's about how you can carry out. So quite the opposite. We have a large-scale customer, which is a major bank actually in US, and they have a very strict maintenance window. And without, they employ pretty high, pretty advanced storage technology and all, but still they need to deploy many vCenter, not because they want to buy more vCenter, but because they want to increase the throughput. So they actually limit the number of VMs managed by each vCenter instance to 500. And so you can imagine there's a lot of vCenter instances, but they do it in exchange for a short time maintenance window.
It's sort of like watching a traffic jam form in LA. Everything's flowing fine, everything's going good, and then there's one little hiccup, and then you have a major traffic jam. And so you can imagine with all of these operations that if there's any latency that is introduced in one of those operations, then there's a follow-on, a cascade effect. And later, you could see some real problems start to occur. So how do we get to this concurrency level without having a traffic jam, an LA County traffic jam? The way we do it is by adding vCenter servers for concurrency of operations. So if you don't have the luxury of a 100-hour maintenance window, we need to compress that maintenance window down. So we do it by adding parallel tracks. So it would be sort of like saying, let's add 2 or 3 more highways through LA so we could avoid the traffic jams. So coming back to the pod and block model, what we do is we add multiple vCenter servers so that we could get a parallel path for power and provisioning operations. So you'll see that these vCenter servers are aligned to the desktop blocks, but they actually live in the management block up here, this green block. So the virtual machines for vCenter, again, it's a server workload, not a desktop workload, so we want it in a separate cluster. But it is managed by all of the connection servers. So it's sort of like we've got these number of vCenter servers, and you see 5 up there because that's one of our guidelines, our recommendations. We've got 5 connection servers here, but really it's at the cluster level. So at the cluster level, I can use multiple vCenter servers. And we have this federated role model, which means that a connection server will be delegated to have all the communications to a vCenter server, and then that connection server is responsible for notifying its peers. So what we see when we look under the hood of View Cluster is that we've got an alignment between a connection server and a vCenter server, and that's where the conversation goes, and that super chatty JMS bus is used to share the information. That's not to say that if a connection server goes down for some reason, that all of a sudden we can't talk to that vCenter server, because if a connection server with that role becomes unavailable, leaves the cluster, another connection server will step up and assume the role. So why don't we talk about, Levin, how we can tweak this concurrency and how we can avoid these epic LA County traffic jams?
Sure. So before you say, oh, wow, I have to install many vCenter servers, some customer come back and say, well, technology advances, right? And we're going to implement, say, local storage, we implement SSD, flash, and that make the Recompose operation much faster. That means, your highway is going to be much more advanced, the car can go much faster through. But because the defaults in View and in View Composer, the queue length is fixed. It's based on some rule of thumb, assuming you have average storage, you have average CPU. The kind of we can't just default to the best of the breed, because otherwise any less performance would get you in trouble. So in the past, discovering the best concurrent limits to set is a little bit like a try and error, a little bit like an art. In a couple of those lighthouse cases, the discovery process was a try and error. We increase it tenfold, something not working, a lot of operation timeout. We decrease it. So honing in that number is a little bit of an art than a science, and we want to create tools to help you make that discovery process much easier. That's why we're working on a tool. Again, this is, I'm a product manager. I'm here to talk about future stuff. This actually, we complete this tool already. We just haven't had the time to put on the Fling. The Fling process is actually something that we can give our tool over there without all the supports limitations that we have on it. And it's, the URL is vmware.com/lab, right?
Yeah, I think it's labs.vmware.com.
Or lab.vmware.com. And you can look for this tool in the near future, in a few months or so.
So just a second on the Flings, I'm sorry. Yeah. The Flings are a place where our engineers can publish a tool that they wrote. I guess as you're doing your job in engineering, you realize, I need a little tool, a little widget, something that can help me either in testing or make my software development easier. Sometimes through the course of innovating that tool and making the job easier, somebody says, actually, our customers might find that tool really interesting and relevant. And so now there's several hundred of these little apps that are totally free. They're not supported by GSS, but if you have an issue, there's a Fling community, and so you could post a question or raise a problem with a Fling. Chances are the person who will write you back to help you is the developer of the Fling. So I would strongly recommend go check out those little tools because they're great, they're free, and so there's some really cool, really amazing stuff.
Right. And this will be one of them. And this tool is a discovery tool. You set up your trial environment, and you set it up in the way that you may deploy it in a large-scale deployment. And then you set this up, and you run it in a single instance. You don't need to run it in multiple instances, because a single instance is great because it hits that vCenter, because the throughput, all the concurrency factor affect single VC. So you don't need two VC. Two is scaled linearly, right? So you use a single instance of vCenter server, run it, and run some of the operations. And what this thing does is it monitors the progress. It monitors various queue size and generate a report for you so that you can set the concurrent limit accordingly and safely. Learning from this tool in the future product release, we will create an algorithm and embed it in Vue itself so that it can monitor its size and self-adjust. So rather than giving you a report, you manually adjust the concurrent limit, we will adjust it for you. That's called the dynamic throttling. We are not there yet because we still need to juggle between safety and what we can aggressively tune that concurrent limit. But this tool, I think, would be a very useful one, especially you're looking into how to increase the concurrency safely and find the concurrent settings that best suit your environment.
So when we take the time to add additional vCenter servers to our environment, we also take the time to adjust the concurrency settings for power and provisioning operations inside the product. And today, in 5.1 and even some earlier versions, we actually have exposed some of these settings in the admin UI. So you can actually adjust and play with these settings yourself. But as Leben pointed out, it's somewhat of a risky operation. So we have these tools in the UI, but we don't provide you any advice to tune it yourself, because basically we would have to tell customers that you have to adjust it to a certain limit until you start to see detrimental effects. In other words, you've got this UI, you could put in a very high number, but you might actually cause problems in your infrastructure. So it's something that you could do, but you have to know what you're doing in order to get there. And so we've had this debate back and forth. Do we just publish a white paper? Do we release a video? Or do we do some other customer outreach, tell them how to do it? But instead, we're going to do the dynamic throttling with a tool. And in cases today where we want to adjust concurrency, we do that in conjunction with engineering. So we make a change, we do some testing, we look at the logs, we make sure that concurrency changed for the better, not for the worse. But we can make some pretty dramatic changes by changing these power and provisioning operation settings. It can be quite dramatic, in fact. One of my customers has 3,000 virtual machines, and they sort of grew to that number incrementally. And they found at the beginning that their recompose time was very, very reasonable. But after a while, those numbers seemed to degrade. And so they found that after a while, their recompose time for 3,000 desktops was 100 hours. And of course, they couldn't take a 100-hour maintenance window, so they were doing some pretty dramatic things, spinning up different pools so that I'm going to move the user from this pool to that pool because I'm recomposing that other pool. And so I visited them on site and took their log files, looked at the configuration changes, configuration settings, their infrastructure and storage and vCenter configuration, et cetera, working with Leben and some folks in our engineering team, and we made some changes. The results were dramatic. They even exceeded my expectations. So with a little bit of intel, looking through the logs, and a 5-minute change that was very easy to make, it didn't even require any downtime, we took their recompose time from 100 hours, which was definitely what? Thumbs down, down to 7 hours, or a 97% reduction in the recompose time. And we definitely got 2 thumbs up from that. So it was pretty incredible, the impact of concurrency on the length of a maintenance window. So Levin, why don't you tell the folks what they have to look forward to and what's coming in the product?
Yep. So I think, we have to, we talk about a lot of the challenges and a lot of the things that we're coming to work on it. And these are the couple of things that we already identify. I go through some of them. But in the near term, it was the incremental changes that we make. For instance, the data store selections optimization. And if you attend my other talks with Narasimha talking about space efficiency, that's also leveraging the vSphere platform to allow you to actually reclaim the loss of the spaces due to, say, Windows 7 aggressive writing into the blocks, the pollution of the blocks, etc. And also, we hear from a lot of customers complaining about when we make the link clones, when we clone from the master images, we inherit the network label, the port group settings. And this affects customers wanting to have a large enough pool, but they have a small subnet setting. Because if you keep adding VM to the same VLAN or the same subnet, you exceed the limits of your subnet setting. So in the near term, we're going to correct that and actually allow you to specify multiple network label and even specify it at a VM per VM level. And we also allow the implemented feature so that you can do a rolling recompose. Because recompose sometimes, no matter how fast you can make it, using treating the concurrence limit, some customers just do not have a maintenance window long enough to sustain any recompose downtime. And so the rolling recompose would allow you to actually take 1 or 2 VMs from a pool, recompose them, return it, and it will resume this process in the background, kind of trickling effect. And that's turned out to be a big deal for some customer who, such as a hospital or clinic, where they can only afford to have 1 or 2 stations in maintenance mode at a given time. And this is really useful for them. Going forward, I already covered the multi-data center view. That has been our focus so that we can really allow you to scale more than 10,000, allow you to organically grow at multiple parts and growing out of the data center. So even if you can do, say, hundreds of thousands of desktop in one single part, that's a stretch. But even if we can do that, a lot of customers come back and say, hey, I don't want to put all my eggs in one basket, let alone like hundreds of thousands of eggs in one basket in one data center. What if there's an earthquake? What if there's a tsunami, right? So that's why multi-data center view support, cross geographic location, across the network, will be our focus going forward. And we will have some, hopefully by next VMworld, we have some demo or some shipping product we can show you how multi-data center view works. And
I was giving you 2 thumbs up.
Yeah. So that's pretty, I think that concludes our the content side of the presentation. We have one website that we put forth. It's called whychooseview.com. It's not a site where we trash our competitors. It's actually really just to help you. Why do you want to choose View? What are the considerations? There's a lot of great white papers out there, and helping you choose View. And last but not least, we are coin operated. We are fed by your feedback. So please give us your feedback and rate us using your iPhone.
We really do look at the feedback.
Yeah.
So before I take any questions, I just wanted to take a moment and thank Levin for a great job. And I wanted to thank you for your time today, your attendance at VMworld. And when we get to the end of the session, we will hang around for a few minutes outside in the hallway. The speaker management team has asked speakers to, when you finish your session, rather than stand around the podium and hold a meeting, to please take the meeting into a hallway, and we're happy to do that. So are there any questions from any of you in the audience?
We have 5 minutes. If you want to just ask a public question, feel free. Or after 5 minutes, we can take it out there and we can continue the chat.
Yes, a question.
View API. Yes, we get that a lot, and the short answer is we will we follow the lead of our platform folks. So in the platform, there's a vModel API coming up. So we are actually actively working on adopting that. And then the current Power CLI will not be completely disappear. It will actually be replaced by a newer set of Power CLI that is built on top of the vModel APIs.
Okay, so we have a question.
Yeah. So you made a point about adding more vCenter servers to a deployment because the recompose operation is slow. Now, is there a way to slow down the recompose operation so that the recompose happens for 5 desktops at a time over a longer period of time so that we don't have to add more vCenters?
Yeah, so that's that's a great question, and one of the ways to slow it down is to lower the concurrent limit. You can lower it to, like, say 2, then you don't allow more than 2 recompose happen. But that's kind of mechanical, and the rolling recompose or rolling refresh feature we are working on. There's a Flink did by John's team. Also today, there's a script allowed to do that, and that's actually achieved the same effect, kind of lowering, have a much more gradual manner of recompose. It worked for some customer, but for some other customer, they rather have one maintenance window, have 700 of them done. They rather do it that way.
So any other questions, any brave souls who want to step up to the microphone?
Yeah, we probably have to hand over this for the next session, so
okay,
we can take it outside. Yeah.
Thank you very much for your time today. I really appreciate it.